Well, shit. Let's start here. I got one guy that sent me this thing here. It's a 442 built. Don't know how many transistors are in it. I think, pull the data card off that one. It's a 442 build amp that we've got to go through that's got a pop pill in it. Then we've got a little ass kicker here. Ass kicker 200 that has got a popped pill in it, pretty sure. And then pull the data tag off of this one here. Whoop. All right. I got this guy, which is a Fat Boy 1x4 that's also got a popped pill in it that I've been through, apparently. As I look in it, I can see my precious little fingerprints of red wire on the inside. So I know I've been here and have been inside her. Anywho, we're going to do all four of these amps together in one smooth linear function. So I'm going to finish one, go to the next, finish one, go to the next, finish one, go to the next, finish one, go to the next. That's the plan. We're going to do it all in one video. So sit down, kick your feet back, relax, because this is going to be a long one, boys and girls. 4 amplifiers, 1 YouTube session. Let's see, how do they say in the porn world? It's a culmination? No, a collage? No. Compilation. It's a compilation video of porn. And away we go. Well, I'm going to invite you guys to look over my right-hand shoulder. We'll start out with this this Fat Boy that I've been through. Let's see what we've got. Let's see what we're working with. Let's see what's going on in the world of Shaun Got Down. With a 1,000 watt 1x4. It is Monday. My phone has rang non-stop until about 10 minutes ago. I'm finally caught up. As in, like, I don't have anybody's phone calls I have to return, I don't believe. And if I've missed you, I'm sorry. I'm sorry. All right. Oh yeah, I've been here before. The variable knob looks okay. This is interesting. I don't see any popped resistors. Our 100 ohm combiner resistor doesn't look to be chooged. I think we're just going to have to hook it up and run it and see what happens here. Make ourselves a little observation science as we go forward. Take our lid out of the equation, that way it doesn't get scratched up. Let's go over here and let's hook it up. Let's see what happens. Wouldn't surprise me if we do have a pop transistor. The 10 ohmers in here are like half watt, which is a little bit too big. Oh, hello, what's going on in there? Let me bring you over here and let me show you what I'm seeing. See the solder slob knob shit that's going on here? That ain't me. This resistor's been replaced. There's a big old blob of solder laying here. That ain't me. And this resistor looks like it's been replaced too. Interesting. It's been a long time since I let one of these leave here with both of those caps still in that box. Interesting. Well, let me go pull that solder blob out of here. And we'll retest, but it wouldn't surprise me if this transistor's popped and this one's popped, because somebody else has been in here. Let me just point out that the seal that's on this box has been broken. It wasn't broken, it was broken when it got here, so we don't know who did what or why or how many jelly beans or who farted in whose Cheerios. We don't know. Okay. Turn on the bench radio. Amplifier is off. Let's fire up our FLIR. So we're not walking through the world blind. Hello, audio. Okay, pass-through tune's still good. Hello, oh yeah. Hello, 1 2 1 2. Hello, 1 2 1 2. Whoa. Both of these 10 ohmers are heating up like firecrackers. Hello, 1 2. Hello, 1 2 1 2. Hello, hello. We got one working transistor out of 4 in the final stage. Hello, 1 2 1 2 1 2 1 2. Hello, 1 2. The flybacks aren't getting hot. Interesting. Wow. Okay. Well, when in doubt, let's pull them all out. What do you think? That's what I think I should do. Now, if we know what we're looking for, we can see that this resistor's been replaced. This resistor here has been replaced. This has obviously been replaced. This has obviously been replaced. And this has obviously been replaced. So what does this tell us? This tells us that somebody ran this thing until it blew up. Then they replaced the transistors, or they didn't replace the transistors, they replaced all the 10 ohmers and then sold it. Huh. Well, whatever. The only one that hasn't been changed is this one here, this transistor right here. But I guarantee you this thing is probably almost completely gone. So we're going to pull all 4 out and replace them and clean up this garbage that somebody's trying to pass off as good solder work, which it is not. And I bet you we'll get her to come back to life. See any of the other little sections showing me that they're having a hard day? Nope. Wow. Oh well, we've dealt with worse. I'll say that much. I am going to make it through this 2x4. No matter hell or high water. So, let me help you understand. Transistors came out in this order, so it should be dead, good, or no, it came out in this order. So it should be dead, dead, good, dead. In theory. Let's see what we got. HFE of 11. Yeah, interesting. Oh, tabby come off. Kissed. Junk. 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 HFE of 11, right here, junk. Get stupefied. Wow. Phone has just been like driving me up the damn wall today. Junk. Diode junction. Junk. Survey says junk. So my original diagnosis was spot on the money. 3 bads, 1 good, and the one that's good is circling the drain of life. Not enough Kuna Matata in the world to save the thing. I'm not going to put 4 new DEI or 4 HG transistors or 3 HG transistors in here that are good. I'm not going to put 4 used ones in here. So we got to go with 4 good ones and not 3 used ones, and the 4th one being the victim of whatever the catastrophic circumstances were. I think whoever ended up getting this box obviously ran it till it popped. And then they ended up putting resistors in it to cover up their mistake of frying 3 out of the 4 final transistors, which is something that we see when you volt something and you run the holy shnikes right off the tires. This is really common. So, not the first time we've seen this. And then he probably traded on my name. Oh yeah, it's a BBI box. I just got it back from him. It works great. I can hear him saying it too. Typical salesman's pitch, you know. All right. Enough. Enough. Let's put a couple more pills back in this thing. Transistors. And let's get on with it. Okay, so all we did was replace the transistors. And we're on 14.7 volts at the moment. The meter's showing 15. That's a 1,000 watt element in forward, 1,000 in average, and a 5 watt slug in reverse. Back from the bird, 10,000 watt dumbing load. Let me show you some drive here real quick. Hello, 1, 2, 1, 2, hello. There's our 20 watts, 25 watts of drive as always. Variables all the way open on the box. Goodbye. Hello, got down. Hello. Over 400 bird, and that's with the 2950 hitting it. And well over 1,000 watts in peak. It's again our 5 watt slug in reverse between the radio and the amplifier. Hello, 1, 2, 1, 2. Beautiful input match. Hello, audio, 1, 2. And I'm sorry if RF is getting into the wireless microphone. Not a lot I can do about it. Let's go up here. Let's flip that into 2x now. Full deflection. What I mean by that is when this meter goes all the way to the right, this one right here, that's 2,000 watts. Our 1,000 watt mark is right here. It's directly between the 40 and the 60. Let me zoom on in, make it a little bit easier for you all to see, especially those of you that are watching it on a cell phone. So directly between the 40 and the 60, or the 20 and the 30, or the 10 and the 15 is that big hash mark that hangs down just a little bit bigger than the rest. That's 1,000 watts. Hello. Hello, 1, 2. Hello. This thing's really getting with it. At 1,300 watts of power. 1,400 watts of power. Now, I can reach down here. And we're going to shut the big power supply off. We're going to start pulling our voltage down. Hello, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1,200. Hello, 1, 2, 1, 2, 133 amps. It's showing right here. Hello, 1, 2, 1, 2, 1, 2. So normal human voltage is still showing 1,200 watts, about 1,100 watts on 13 volts. Down on 12, it makes about 980 watts of power. This box is right. and it is screaming along. Okay, I'll button this one up. We're going to move on to the next one. Away we go. Well, I'm home from my week of road trips. This is a lot of driving this week. One trip took 2 days and 14 hours of drive time, and I got to show you that. And another one took, well, an additional 2 days and an additional 12 hours of drive time. But I got my parts accumulated that I need for a couple different things. One's a project, the other one's an upgrade. And so here I am where I left off, what was it, Monday of this last week. And as you guys just watched, I got that 1x4, 2x4, pardon me, 2x4 that does 14 million gajillion watts done. So let's jump on to this. I don't know who built it, no name. This is like a little 1x2 cabinet. I vaguely remember talking with him about this, and he has basically turned me loose on everything here. So let's just take a minute. Let's go inside and see what we have. That way there's no more mystery on what we need to do. What we're looking at. Oh, it's a little 2-pill, 2290 or 2879. Small transformer. Okay, well now we know. Change point of views because I got to have access and I can't. I've got a lot of things I need to get done the next 2 days. And you guys can follow along, but I have to work on this here. We'll come back to that. You guys can follow along, but I got to stay focused on the prize here. They're smushed, but they're not soldered. So let's go over here. Ooh, white LEDs. Yeah. All right, let's hook this up real quick and let's run it. Change points of view once again. The reason we're gonna do this is, like I was saying in the previous little segment, is I've got to hustle. I got a lot of things I want to do, and not a lot of time I can get them done in the next 2 days. I need to get with it. Me dancing around this big tripod with this big ass camera is not one of them. It's kind of counterproductive. Okay, so we're currently on 12 volts. Soldering irons are plugged up and turned on. So turn this on. We're gonna put this at 1x. Take my word for it. No, don't. Here, I'll help you. $1,000-watt element and peak. Everything else is the same. I think at this point, if you've watched any of my couple thousand YouTube videos I have, you understand this is 5 watt, and this is in bird average or RMF, root myth squared. That's in peak today. So start up with our 2950. I'm gonna put no watts through it. Hello, 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 hello. Okay, 20 watts, no input or no pass-through reflect. So I'm looking at the RF coming in. Its reflect as it's going through the box out to the antenna. I have zero signal effect. Hello, hello. Well, it doesn't even. Hello, doesn't even key up. So let's turn that little guy on. Let's go over here and grab one of these. Come on, big girl. I know you got it in you. Yeah, you do. Okay. All right. Let's make sure we're on ground. We are. We're keying on ground. Relay latches up. Hello. Hello. Dead short. Hello. Nothing. No signal, no nothing. Transistors are not getting signal, or they are getting signal, and how do they have this wired? Okay. 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 Either the builder was dyslexic or I am dyslexic. And I think we all know the answer to that question. Well, at least I don't feel like such a retard. The keying circuit has definitely popped. Hello. Okay. Hello. 1 2 1 2 1 2. Hello. 1 2. So what we see this making here is about 350 watts of power. So we need to repair our keying circuit. We have no pass-through issues. Both transistors are lighting. And we're only making 300 watts of power. This will not last. This garbage Alibaba cap's gotta go. Cornell Dubois style caps here. This needs to be upgraded here. And this needs to obviously be replaced. The key-in transistor. So let's do all of those things. So I have this standard called minimum safe. Okay. And minimum safe is whatever I determine is going to be inside this amplifier. Because once it's here and I work on it, my name's on it. And I basically, not only do I own the previous builder's craftsmanship, but I am now responsible for if this thing shorts out and burns to the ground or causes a guy's truck to catch on fire or whatever, right? So therefore I have to take sole responsibility for, well, the internal layout and the design of the damn thing. So it's a big burden to carry, but heavy is the head that wears the crown. First thing, minimum safe. This right here violates my major rules of minimum safe. Okay, that is no good. This is way not safe. But what's really not safe, and I mean unbelievably not safe, that's just like, Jesus, take the wheel of my car and drive me all the way across the country. It's not going to happen. You're going to end up in the ditch dead. Well, if I wasn't to fix this and repair all the chicken poo solder work in here, I'm not technically responsible, but I own the responsibility, okay? It's like I see that there's a flaw here and I need to fix this. Now this is so simple, this is just a little piece of double-sided stick tape. That's all it takes to fix this. This is the cheapest of the cheap that I've ever seen. They didn't even use pill strips. They cost $1.90 for a 16 pill lot. It's stupid cheap, but this is a creative workaround. So we have to secure this to the board somehow, which we already know how I'm going to fix this. We have to secure this to the board. There's no protection fault diode here. There's no snub diode here, hence the reason our keying transistor is now garbage. Holy smokes, what the holy shit. The keying transistor's not even assembled properly. Okay, so focus. I've got 2/3 of the field of view with my hand here. Hello, focus. Focus, you. Oh. Paging Mr. Black Productions. Paging Mr. Black Productions, can you please buy us our new lens that's got image stabilization and a decent autofocus? Dear Lord. Okay, so this diode here, this glass diode, needs to go to the center leg of the transistor. I mama wanna garbage. You know what? Here, I'm gonna make sure it never sees the light of day ever again. Right into the effort bucket. Okay, let's make this thing minimally safe. As in, like, let's clean up the solder work here on this board. Let's get the rest of the solder work redone. Let's get this board attached and fixed. Let's put a strain relief on the power wire so we can't jerk this out and cause an electrical short and a catastrophic fire. Let's get this secured as well. And maybe we can slide it over enough to where it's not sitting on top of the pill strip and there's not an energized circuit right underneath the coil of the relay. It's just little small things. It's the little small things that count. Okay, so we got the relay out, and I went ahead and I reworked most of this because there's a lot of little different things here that I'm not too interested in keeping because the solder work was so bad. This is our ground wire. It was attached here. It was only attached with 1/4 of a connection. I want to get rid of this bullshit Alibaba blue garbage capacitor that they don't hold. We're going to mount our relay like this in here. And yeah, we're just going to rework our keying circuit completely. Went ahead and added a snubbing diode to the relay so we don't have to worry about blowing out our keying circuit anymore. So let me get some tape on this and get all this resoldered in. We're going to replace this piece of mini coax that wasn't soldered in very well. Because remember, once it leaves here, if it breaks, I'm the one that has to fix it again. Ugh. Okay. Talk about I have to change damn near everything in the damn cabinet. So we gave it the power wire upgrade, and we found out this transformer is ammonium materials. It looked horrible in the spectrum analyzer, and I could not get it to tune. It's making all kinds of wild watts, but they were all over the place. So I went ahead and replaced that with one of my custom-made transformers for myself, and it's settled down as far as the power output went. Cleaned it right up. So now there was no soldered ear tab for the fan mount in here, so when I said I needed to work on this in the beginning of this particular amplifier, this is what I was referring to. It's going to need to add a little 10 or 15 ohm resistor to help protect the electronics in the fan. So that's all added up. So that's done. And that joint looks like poop. So this took me a lot longer to get this 2-pill straight. I'm like, God dang, this is just a little 2-pill. What the hell? Had to flip the relay around. I also changed. This just broke off. Look at this. Oh, mother God. Everything in this box has just been barely working. And I mean barely making contact, barely soldered together. Oh, I'm just like this close to getting it finished. Nope, guess what? You're not. Start over. The wire's not even soldered. It was just twisted together. I'll be damned. I could have completely rebuilt this 2-pill from scratch. And the amount of time I've had to take it apart. Like the two 120 puff capacitors that are down here. Couldn't get it to tune, couldn't get it to tune, couldn't get it to tune. Finally figured out that those were 380 puff capacitors that were in there. I changed those out, the circuit settled down. Then it had, I don't know why, but it had 2 of these 103 caps attached to the back of the output transformer, which was making it do a little bit more watts on a watt meter, but it wasn't power, it was intermodulated distortion or some crap. It was garbage. It was all over the band, frequency-wise. Took those caps off, that settled it down. That's when I finally decided, you know what? I'm just gonna make the move. I'm gonna go to one of my transformers. That way we have a known variable. Like, I know what this is, I know what this part is, I know how it's gonna load. I don't know what he robbed that transformer out of. Here, come apart now. Heat shrink based everything. Okay, let's come over here. Now that we've got the non-fun part, so far this little 2-pill has not been fun for me. No fun for BBI. It's just a little 2-pill. Okay, first things first, third things last, safety always second. Here's our pass-through tune. Hello, audio 1 2 1 2. We got our 20 watts through it, so it's obviously good. But that doesn't mean anything. Hello, 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 hello. Good input tune, or pass-through tune, I mean. Flip the on switch to the on position. Hello. 20 watts gets us 400 watts out. Hello, 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 hello. Here's our input tune. Hello, 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 hello. Hello, 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 hello. That's nice and good. Good and strong. Good and strong. Hello. So, now, let's take this, the 2950 out of line. We'll hook up the 955, which I haven't used in forever. Yeah, the coax is broken. It's tripping. I don't know what the deal is. I'll come back to it. It's beeping. You know what? I'm going to use your big brother. I am. I'm going to use your big brother. Hello. 450 watts. Hello. Is what it is. This thing's working. Makes roughly 500 watts of power. Of course, voltage and coax lengths and all the normal diplomacies apply. So, on this breath, let's get our fan installed. Let's come over here and move that out of the way for the moment. Sorry, I got a large amount of stuff I want to get done the next 2 days or day and a half. I've got a very rare opportunity to get a lot of ground covered with no distractions. And I really want to utilize it, and I've spent several hours of this precious time working on this thing for whatever reason. Okay. There we go. Slap some screws in this, and we're on to the next one. Okay, so complete reset here. It meant, you know, I wish the world would open back up so I can go get some new towels. I've got this thing, which I had to trim a bunch out of, and starting to get a little frayed around the edges there. This is an Ass Kicker 200. The original real deal Ass Kicker. Kind of a cute little box. but it doesn't have stock power wires in it. So I'm kind of interested to see what we find on the inside. I don't know about you. Oh, cool. It's got torque bits in it. There's slots. Slot Torx is weird. And they're stripped. Of course they are. It's okay. I've got the fix for that too. He doesn't know what happened. He doesn't know how many transistors are blown. He don't know. He don't know. What do we have? 2 MRF 455s. Very, very, very basic. Wow, the traces are almost disintegrated to dust. Check this out. All these traces are so corroded they're almost dust. Interesting. Interesting. I think he might have been hitting it a little hard. A little bit brown. That's on our low and our high switch. This is very Messenger-esque. This reminds me actually of the Messenger M80 and that Messenger 150 on the inside. Same heat sink stock, same kind of configuration, same kind of lid. Exactly like the Messenger 150. The M150 or whatever it is. This front fed transformer and everything. Before we get too carried away here. So the one with the fuse, deceivingly to the eyeballs. This is ground, hooked up through this butt splice. Right here, ground. So and it was a bad coax connector on my Striker. The connector finally pooped out. So let's see what we got here. Antennae in the hole. This thing's rusted. Woo! Rusted. Okay. And our always faithful 2950 turned down to 20 watts to keep us from killing the finals. Let's see, we got a light. Cool, preamp is working. Let's see, can we talk through the box? Hello, no we cannot. Okay, so no pass-through RF. Hello, hello, hello. As we can easily see represented here. Radio keyed, hello, hello, hello. And look at our input tune over here. Hello, off in the corner. Now we know that's not a bad jump hair. Something internally in this box has gone away and is most likely the relay. It's okay, I've got more of those. Let's see what the relay does here. Hello. Now that's entertaining. Wow. Hello. Oh, this is going to be a bag of monkey pee-pee. Check it out. So it's a 1000 watt slug in 1X. And here's on. Hello. 1, 2. Hello. Check out our input tune. Hello. 1, 2. Now, piss on this. Come here. Come here. Hello, 1, 2. That's the amp on. Amp off. Hello, 1, 2. Lock down camera. Sorry, everybody. I apologize. We're experiencing technical difficulties here with our giant, jamnormous, friggin' camera. Hello, locked in the corner. Off. Hello, locked in the corner. On. Hello, locked in the corner. So we don't know what we've gathered from all of this. We've gathered from all of this. This box is hoot. Hello. Now we can talk through it. What is going? No. That's the amp on. Amp off. Hello. Hello. This is going to be a long day. I can tell you right now. Starting to question all of my coax ends at this point. Because 1 minute I can talk through it, the next minute I can't. Then 1 minute I can talk through it, the next minute I can't. Just had the 955 give me problems, so. Hello. See, now I can talk through it. The amp is in the off position. Amp is in the off position. Let's come back up here and let's take a look at this. Hello, 1, 2, 1, 2. Hello, 1, 2. Hello, 1, 2. Hello, 1, 2. Let's turn the amp on. Hello, 1, 2. We got no key up. Hello, 1, 2. Well, let's go figure out why the key in transistor's blown, if that's only our problem. Well, let's start over here. So first thing, I manually bypassed the relay, and I got it to key up, and I recognized, okay, we've got a couple good transistors, I think. I didn't really look at that too long, but what I did recognize is the stock relay is welded. You can hear it trying to move, but it won't move. So the leads on this relay are frozen in time, which usually lends me to believe that when I see that, what has happened is a coax connection, the coax in itself, some places either become pierced dramatically, or a connector got ripped out dramatically, or something shorted catastrophically while in operation. I don't know what the circumstances are involved with this box and how it broke. I don't really care, to be honest with you. At this point, I'm just wanting to get as much done as I can in this short little time frame that I have to not be interrupted and to get things done. So we replaced the relay with a brand new one. I think it's a 2 amp, 12 volt, half amp or 0.6 amp, 120 volt relay that runs on up to, I think 25 volts. But so I replaced the relay, and I went to go run it, and I'm like, what the hell, man? I'd turn it on, and I'd have key up light over here. The key up light was working. I'm like, well, how that works is that works piggybacked off of the auto transmit transistor here in the back. this little NPN. I'm like, well, if this is working up here, why no for my new relay not go switch? Remember how I said the traces on this thing were about rusted and corroded to death back here in the corner? I went ahead and cleaned those, and you'll never guess what. The internal resistance of that trace has gone to infinite because it was rusted and corroded and oxidized all the way through. So I went ahead and I took like some, what the hell is this? Little tiny fartsy wire here, 24 gauge, solid core, craft wire, and retraced the trace, soldered it on past the corroded point, remade contact with our positive leg. This is our positive post. That's our switch ground post, by the way. This guy right here. So as soon as I did that, I mean, it took me a few minutes to work that around in my head. I'm like, I'm probing here, I got voltage here, and I'm running it down the trace. And if I push on it just right, I was like, no, let's fix it. So that is repaired. This trace is still good. I went ahead and cleaned it. It's like somebody had got pop in here somehow. Because when I got it wet with water and touched it, it was real sticky, like it's sugar-based, something or other. I don't know. I'm going to move on. We went ahead and we removed the 50 ohm resistor that was here. And this is on our low on our high circuit. We replaced this with a much bigger, much more substantial 50 ohm resistor. Now, listen. This is a rare phenomenon because there's no air circulation inside of the cabinet. Things that get hot have a tendency to stay hot. And when traces get too hot, eventually they get to the point where they can't hold no more solder. So the next thing that drew my attention as I was sitting here fingly farting around on the inside of this is let's look at how hot this has gotten right in here. And here on the positive rail, it's also black. Very black. But look at how hot this is here. These legs aren't attached to anything. That's the trace bending out of the way. Look at that. Because this leg isn't even hooked up no more. This thing has been run hot as hot can get. And the parts are starting to come off. All the solder on the top part of this output transformer has run down and is globbed up around the base of the output transformer. I still believe we've got 2 good transistors in this box. I'm wanting to believe that. It surprised me if this cap's going to even read remotely good. So let me get this pulled off. We're going to reflow all this solder here, add a little bit of flux to it. We're going to put a little bit heavier duty your cap here probably, and we're going to beef up this connection here in the back. You can see once again this has also gotten so hot that it's starting to black. And of course, obviously, we're going to do a power wire upgrade to it. But I needed to point this out that this was the primary reason for failure. If anything happened internally in the box, the relay is a sign of something external that there's a problem. So, is what it is. Okay, moving on. So I'm just glad CB-Trix is back. It's just living proof that if you put enough money in anybody's PayPal, it is what it is. A group of us got together and hopefully we gave him enough money to keep that running for a while. Very hard person to get a hold of, by the way. So I go and I look at CB-Trix and I look at the Messenger 250, the 225, and the Messenger 125. Messenger 125 is a single transistor device, so there's no data for me to get there, but I went and looked at the 120 or the 250 or 225 and the 250 and C11 and C17. One model is C17. The capacitor listing is for 1,000 puff, and so on the 250 it's 1,000 puff, and then I went over and I pulled this exact same amp off the shelf. Lo and behold, it's a Messenger 250 of a customer's, and it's a 1,000 puff capacitor. This guy right here has decided to die. It's got about 497 worth of puff left to it, picofarad, worth of capacitance left to it. And long story short, we're on 12 volts at the moment, you guys. Oh, and I did a power wire upgrade, and I put a grommet on it. Okay. Grommet's pretty important in my world. I have a small mental breakdown if I don't see a grommet. Like, fire, smoke, flames, bad shit happens. It's not minimally safe. I mean, there's a lot of stuff we can do inside these boxes. There's a lot, a lot. But we have to maintain a minimum safe standard, like grommets, soldered eyelets, just simple things like right size coax for things. Make sure that we've got everything bolted down or secured to the board, kind of thing. Just basic stuff. I went to clean all of this, and the top part of this transformer has been so fried that the pound down paper millimeter cajillion meter wafer thin copper has, well, I put a soldering iron to it and it basically just disintegrated. So I went ahead and I put trace tape across the top of the transformer and cut it so it matches the top of the transformer, and then floated into the top of the tubes. And then I had to do the same thing down the side of the transformer, down these sides, to get this to hold any solder, because I don't have any of these little tiny transformers. So I just rebuilt what I had, electronically washed it and cleaned it all up. And these are our end results. So we're going to go back over here once again. This is a 1,000 watt slug in peak, 1,000 in average. So let's turn off the amp. Hello, 1, 2, 1, 2, 1, 2. Remember, we're on 12 volts. We're putting like 11 watts of power into this. So let's turn on the amp. We're going to start out in low. Hello, about 160 watts, 170 watts. Let's go to high. Hello, audio, right at 200. So we're just running on the ampacity and the batteries at the moment. Let's reach down here. Oh, yeah. Hold on, before I get that far. Let's go up here. Getting ahead of myself, guys, sorry. This is our ability to talk through the box. Hello, 1, 2, 1, 2, 1, 2, which is a good resonant pass-through, low input or low pass-through reflect. Let's turn the amp on, or run the amp in low. Hello, 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 hello. Okay, now let's go to high. Hello, 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 hello. That makes me happy. I can live with that. I have no moral qualms with sending this out of here. You guys got to remember, gentles, kind men and sirs, let's take a minute. Let's hop in the Wayback Machine. Let's all go back to when we were in our 30s and 20s. And most of your average radios did 25 to 30 watts. Not the world that we live in today where everything does 50 and 100 peak. Okay? A peak number, I don't care what anybody's got to say, is an actual real unit of measure. So, in the day, with 30 peak watts, that was about all you wanted to put into this little box. That's it. So, hello, 1, 2, 1, 2. Reach down here. Let's turn on the turbo overdrive machine. Let's bring our base voltage up on a little setup here to about 14.9. Hello, 250 watts. Arguably pretty stable. Hello, audio, audio. I've got one of these out there running around in the world of sound that I went in and I gutted all the garbage out of the inside of it and got rid of all of this, the weakest link in the box, which is the relay board. Arguably the weakest link in the box. We got rid of all of that, and I turned this into a Class C monster driver for a guy. I used two 2290s, and guess what it made? 500 plus watts of power. This is not that. And I don't think this guy wants to sink that amount of money into this little guy. So this is fixed. Now let's get on to the last one. So the problem that I was having with the ass kicker initially, and I think might have been part of my problem with the unknown 2-pill, is this here. I just went ahead and lopped this off, and that's the only amount of strand that was making contact here. This is my fault, this right here, this failure. And the reason I say this is my fault is because you're supposed to let the jacket go up inside the downsizer. And when I put this together, I thought I had done that exact job. And apparently the jacket had slipped down just a hair. So when I tinned the jacket, it flowed all the way back down the coax connector and made the braid very stiff. And we had fatigue failure after 9 months of use. So this is my fault, 100%. We went ahead and made the appropriate adjustments over here on this connector. It is completely rebuilt and done right. And I had roughly the same issue take place here with the 955 connector. It has also been repaired and redone. So I wanted to point that out. That was the problem that I was having earlier. And I also realized I was going too fast and trying to get too much done too quickly, and I was missing the obvious thing that was right in front of my face. So that's fixed. Like I said, on to the next one. Well, this will be amp number 4. Once again, guy's a little sketchy on the details, but that's okay. We get her fingered out. This is built by the same guy, I think, that built the 2-pill. Which, if that's the case, yeah, we'll see. I think. Seal's still intact on this guy. It's alright, we got its medicine right here. That one was really loose. Okay. Definitely the same guy. Well, shit. Let's transistors are barely even soldered in there. Well, this one's got pill strips in it at least. I don't see any obvious burnt parts. Of course, they've repurposed a pill strip for the distribution bus. This is never good. Got split capacitance on the output combiner. Never ever want to do that. It's all full of these blue caps, which I can almost bet you money that's where our problems are going to be, if we have any. These are floating loose and banging the cabinet. Yeah, Okay. This has got to change, that's got to change, that's got to change. Change, 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 change. Change this, change this. Probably get rid of this very prone for failure coax. Probably go to RG400 or something. Whew. All right. God, the on-off switch is loose. Everything's loose. The ground nut is a carriage bolt that's been cut. It's got another nut against it, and then the nut on the outside stripped. So I'm going to have to replace that here in a minute. But I think we got a decent enough connection that we can at least test it. Hello. Pass-through tune. It's not horrible, but I can fix that. Hello. Makes 600 watts. Once again, 1,000 watt slug-in peak here, average, and then a 5 watt slug-in reverse. Let's make sure all of our transistors are turning on. Hello. 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 Okay, input tune is really bad. So if I'm only putting a couple watts in this, right? So we're down on 12 volts. We're putting like 15 whole peak watts in this thing. So about less than 5 bird. Hello. Pretty bad. Pretty bad. Oh, this has got me so worried. That's so unsafe. I don't know. There's a lot of fun stuff that we're going to do inside this thing. I can tell you that right now. All our transistors are working. We could sit here and play with our tuner if we wanted to. But, man. Let's turn on the Speccy Analyzer. Let's take a look and see what it's doing before we start messing around with anything. Good old Signet. Daddy love you. So we're 100 and some. Center's at 100. We're 200 kcs wide. So we're pretty much going to see the whole spectrum here. That's our radio. Hello. Oh, God. All right. It's not really fair to do it with modulation. And that's with, I believe, 5 watts worth of input power. Yeah. Okay, well, we now know what it does. Hello. A 580 watts peak with 20 watts of drive on 12 volts. And about a third of that's on frequency. Ish. So I've rebuilt this side of the box now. I got rid of all the shitty, cheap, Chinese capacitors that were in this thing. Cleaned up our Class C ground chokes. And then I went and incorporated some skullcracker technology. That's what we've got going on here with this board. I wish I could say I came up with this. I did not. This is straight out of the Skullcracker Nation playbook here, this board. I'm going to put one on the output side as well. So this is all cleaned up. It's got the balancing resistors where it needs to. Everything is locked down. Nothing can move. Now it's safe. So the input side of the circuit I consider to be stable. Okay? As in, like, I can trust that this thing can bounce down the road in a dude's truck and none of the parts are going to ever jiggle themselves around to where we're going to have a problem. Okay? Don't have to worry about anything shorting out, the input shorting out, blowing up the driver. None of that stuff. Now the only thing that I don't have hooked up is some kind of tuning circuit on the input. Now we added a bunch of inductor by doing this, total surface area. So of course the input capacitance is going to change. That, and I don't want to have any capacitors here. That's what causes all that harmonic garbage that we just seen in the last segment. So now we've got this half of the amp done. When you see the other side, you'll notice the dramatic night and day change. Okay. So all of this is dangerous. All this stuff floating around, it's able to move, could possibly short out, shitty foam-filled coax that melts versus clean and steady and rock solid. Rock solid, clean and steady. Yeah, enough said. Now, to make this work the way I want it to, we're going to change how the power wires sit in here too. We're going to put the power distribution down underneath the output transformers, which I've done successfully many times in the past, and we're going to do it again. And then we're going to replace all of these blue garbage capacitors. So, first things first, let's clean it up and get all the parts out of here, and then we'll be right back. So let's start here. We got it all running now and all tuned. For some reason, it wanted a lot more inductor. This circuit is not my preferred form of building. It never has been, it never will be. Electrically, it's not very efficient in my mind's eye. Just measuring the amount of current that the box takes to run tells us this, but it produces a ton of watts. No more than my normal way of building, but it works. So it wanted a bunch more inductor, which we had to give it. It needed more inductor, and instead of being able to put the capacitance here, because the induction is already so high in these portions of the circuit, because it's not a balanced fixed system, like there should be capacitance here and capacitance here, it didn't want that. Whatever you do, you don't ever want to put capacitors on both sides of the splitters. There's always a little bit of difference between the capacitors, and it causes radically rad harmonics, I'm here to tell you. So we were able to snub that out. Like I said, I got rid of all the Chinesium caps over here, but we got this thing fairly tuned. Let me turn this up on its side. So we did the same thing to the output network. We put some Skullcracker Nation technology up in here. We put the boards in it. I went and I did a power wire upgrade by putting the distribution bus, which is an actual 3/4 of an inch wide piece of phenolic that goes down underneath the output transformers instead of a piece of pill strip with some wire on it. We upgraded all the power wires going and feeding all the transistors, which is a little bit more help, taking into account this box is going to pull more current than an average 8-pill. Then we went to RG400 coax, which is Teflon based dielectric, which means you're not gonna burn it. We got rid of the capacitor here on the output tuning network right at the relay, which is good. These are good things. Put a variable capacitor in it to get it dialed in spot where it needed to be. And the end result, fairly impressive as far as the power is concerned. Let's go, let's zoom in here. So let's make everything read our stock face value. So this is in 1x, that's 1,000 peak, that's 1,000 average, and of course the other one's a 5 watt slug in reverse. Back from the Bird 10,000 watt dummy load. Now we're hitting this with a 490 at the moment. So we're gonna put about 180 watts of drive into it. So 180 watts of drive gets us Hello. Off the scale. Off the scale. Off the scale. Go to 2x. So now full deflection on this thing. Full disclosure all the way to the right. The 20. Or pardon me, the 25, the 50, and the 100 on the right hand side. That's 2,000 watts. Hello. So we're seeing a solid 1,600 out of it. Now let's go up here. Let's take a look at the 490 slug. It's a 5 watt slug in reverse. Hello. Hello. Half a watt of input reflag, which that was a nightmare to get on this girl. Yes, you are. You're a pain in the butt to tune. Yes, you are, but you're good to go now. This will require a little bit more drive than your standard 8-pill, but it's making the power. Hello. Hello. 1, 2, audio. 1,600-ish watts. Pretty stable. Now, I have not played with this, with the Bench 2-pill yet. I should probably give that a try. Give me a minute, let's just hook that up. So let's start off here. We got the Bench 2-pill now online. Using the 2950 to drive it all. It's a 1,000 watt slug in peak. Hello. We're right at 200 watts input power. Run that down, flip that up. So now we're in 2x on the meter, and the 8-pill is on. Hello. Shoot, I just showed it to you in 5x. I totally lied to you guys. Well, if you're paying attention, it made 2,000 plus watts, but it's all good. Here, let's do it this way. Now we're in 2x. Hello. 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 It's making the power it's supposed to. Here's the downside. In Class C, this thing should only pull about 180, 190 amps. Audio, audio, audio. 246 amps at 14.9 volts. So the moral of the story is it's going to take a big power supply, and it's going to take a little bit of drive, but it gets up there. This is built a lot kind of like a Dominator or a Foxy or a Prime Minister kind of style with some other twists on it. The downside is I don't really know what the material make is here. I think it's type 47 on the output transformers. I'm not too sure. Combiner ferrite, I don't know what this is. But nothing's getting hot. It's making the power it's supposed to. It didn't have any bad pills in it. It just needed a lot of rework for safety, primarily. And the reason it wasn't working, I think, is because the power wire came off the relay back here from the power switch. So, okay, on that note, we're going to wrap this duck bucking show up. Let me put the case on this, make sure the fan's running, and we'll be done. Hello, 1, 2, 1, 2, hello. It's working. Everything's working fine. I'm happy. This makes me happy. Well, here we are at the end of the show. I went in and put a label on this because I'm not the one that built this. It's a 442 rebuild. Same guy that built this. This one was our biggest struggle. There's a lot of problems with this guy. This thing is good to go. 2,000 watts, 1,400 watts. Now, it's like I told the customer, I said, listen, this is like a 15 or 20 watt radio max drive. You put a heavy duty radio in that does like 45 watts, you're going to end up right back in the same position you were at when the thing came in. Pop pills. Bad news. So at the end of the day, This guy will drive this guy will drive this guy, that guy stands on its own, but everything fixed. It's all working now. It's all working safe, as in like there's enough good parts put in the right places, holding everything in place that I feel comfortable letting it leave here all of these. So on that note, we're gonna run away. We're gonna sit down in front of the computer and edit all this stuff together on this beautiful, beautiful weekend. So gentlemen, my name is BBI, and without a shadow of a doubt, I am the biggest mud duck out here in Idaho, whatever that counts for. I have no flipping idea anymore, but it is the facts of the land. I appreciate y'all tuning in, following along on this little saga. Big shout out to Excess Power, big shout out to Siglent, and a big thanks, honestly from the bottom of my heart, all of you guys. I appreciate every single one of you. I never take you for granted, and I'm over here whittling on this pile as fast as I can. I've been telling everybody I'm going to take work in September. That might need to get pushed maybe another month, but we'll see. We're going to do the best that I can. So on that note, I'm out of here. You guys have a good week coming up. Bump, bump. We'll see ya. Bye.